Hi children and viewers. In this video I am going to start new lesson, that is motion in a plane. Children, in this video you are going to learn about few things. This is the one of the most important chapter for public examination point of view. That's why you have to focus on the entire chapter. So children, in this video you are going to learn about few things. What is a vector and what is null vector, and what is unit vector, and what is position vector, and what is mean by equal vector, and what is mean by unequal vector, and what is mean by equal vector, and how we can add the subtractions, how we can add the vectors, and how we can subtract the vectors, and how we can divide the vector into number of components, that is the resolution of vectors. So children, in this is the nothing but introduction of chapter. If you know about all these things, next coming topics will becomes very easy. In this entire video, one 4 marks question is there and one 2 marks question is there. What is the 4 marks question means? Define unit vector, position vector, null vector. That is the one question for 4 marks. And define unit vector or null vector. That is the, if anyone ask for 2 marks question, that is there. And addition of vectors and magnitude of vector, how we can add the vectors and how we can find out the unit vector mathematically. So for 2 marks question is there, that's why you have to watch it carefully. Children, first thing here, I'm going to topic without any late. Children, motion in a plane. This is our chapter. In that, what is a vector? Children, in previous chapter only I explained what is a vector. A physical quantity which has both magnitude and direction, that should be called a vector. A physical quantity which has both magnitude and direction, that should be commonly called as vector quantity. Vector quantity must be have both magnitude and direction. Clear children? So if you want to represent the vector like this, how we can represent the vector? So generally, while we are writing, for example, this is now a letter A. Clear? If we can keep above the letter A, we are keeping some arrow mark like this. Now it is a vector. That A is vector. Clear? This A is, for example, A is a physical quantity. We are showing that it is A and it is A arrow. Now it is a vector quantity. That means while you are writing any physical quantity and you are keeping an arrow mark above the letter, now it is treated as a vector. It is treated as a vector. In this way we can represent the vector while we are drawing, because here this is the vector we are showing like this. This is the vector. Generally we can call this is the initial point and this is the final point of vector. Final point of vector. So in other words, we will say this is the tail and this is the head point. Clear? Anything you can follow, either it is initial point and it is the, or it is tail. It is the final point or it is head point. Clear? So generally a vector should be shown like an arrow. An arrow. Here length of the arrow is here magnitude. Length of arrow is nothing but magnitude. What is it children? Length of arrow is what? Magnitude. And that arrow mark symbol will shows the direction. Got my point children? While we are representing the vector, we are showing like this. This is the vector arrow. In that, this is the tail point or tail part, or it is taken as initial point here, and this is the final point, head. Here what I am telling, this entire length can be taken as the magnitude and the arrow mark symbol represents the direction. Clear? So length is magnitude and arrow mark symbol is shows the direction. So that is having magnitude is there and direction also there. That's why it is called as a vector. Clear children? So while we are writing any physical quantity like that, that will represent the a vector and vector. Clear children? So but while you are reading, while you are watching or reading anything, something in the physics textbook, sometimes you may find, for example, this is the A. So while you are reading in any paragraph, that is showing like this, bold type letters. So now it is the vector A. While you are pronouncing, now it is vector A. Even though there is no arrow marks above that one, but it is simply here, it is the bold type letter and that should be having some thickness like that. Now it is called as vector. Clear? So in this way we can represent the vector. Clear? While you are writing the any letter, if you can keep above the arrow mark symbol, it can be treated as a vector quantity. And while you are reading any something content in your textbook, if you can find some bold type letters, then that bold type letter will indicate the vector quantity. So in this way we can represent a vector while we are reading and while we are writing. And children, so now here we are writing, it is A is the now vector. And children, if we can write like this, mod of A. Now it is nothing but magnitude of vector. So later we discuss. So children, this is simply about a vector and how we can represent the vector. Okay children, now what is mean by equal vector? What I told you children, a vector must be having some magnitude and direction. So a vector must be consist of these two, magnitude and direction. Children. So in this case children, for example, I am saying now this is the vector A. I am showing like this. And this is the another vector. So here simply children, so this is the another vector. Now in this case A and B are called equal vectors. Vector A and vector B both are, what I would say, equal vectors. Why? Because both are in same direction and their length also same. Their length is nothing but what I told you just now. The length is nothing but magnitude. So children, here this is the length and this is also length. So both are having same magnitude and same direction. Then those vectors are called equal vectors. The vectors which are having equal magnitude and same direction, those are called equal vectors. What we call equal vectors. For example children, now this is A and it is B. This is A and vector A and this is vector B. Now in this case, almost all both are having same magnitude. But both are in different directions. Initially what I told you, these two are having equal magnitude and they are in same direction. Then what we call equal vectors. In this case, they are having equal magnitudes but both are in different directions. That's why they are called unequal vectors. For example children, now here this is the vector A and this is vector B. In this case what you observe, magnitude is same but direction is different. But in this case children, direction is same direction is same. Clear? But magnitude is different. Magnitude is different. Then also these two are called unequal vectors. That means if they have two properties are same, then they are called equal vectors. If they do not have same magnitude or direction, that is what we call unequal vectors. Here two possibilities are there. Both may be in same direction but unequal magnitudes, and both are having equal magnitude and both are in different direction. So in this case, for example here, so equal magnitude, different directions, same direction, different magnitudes. Now in this case what we say? Different magnitudes and different directions. Different magnitude, length is different. Here different length, that's why magnitude is different, and direction is also different. That's why here unequal vector means in these three anyone is possible. Here magnitudes are different, directions are different. Here direction is same, magnitude is different, and here magnitude is same, different directions. That means unequal vectors means these three conditions may be any one of the takes place. So children, this is about the unequal vector and equal vectors. And children, now we will go for addition of vectors. Children, this is very important for examination point of view and other competitive exams also. This is one of the best topic here, addition of vectors and subtraction of vectors. Watch carefully children. So generally here addition of vector is based on the triangle law. So it is also called triangle of vectors. Triangle of vectors. Addition of vector children. So watch carefully here. Addition of vectors. So children, addition of vectors. So for example children, this is the vector A. So children, I am going to explain this now. A plus B is equals to C. We are adding the vector A, vector B, then again we are adding another vector C. So for that I am going to explain by taking the vectors according to the triangle of vectors. So children, what I told you, this is initial point and this is final point. Clear? Now this is the what it is, vector A. Watch carefully children. This is the initial point of first vector A and this is the final point. After that we have to add it like this. So how we can join like this? Clear? So again what it is, this is the final point and this is the initial point of second vector B. How we added children? Watch carefully children. This is the initial point of A and this is the final point of A, and this is the initial point of B, and this is the final point of B. How we can join? The initial point of second vector must be joined to the final point of first vector. Clear? In addition of vectors, we must add the initial point of second vector must be joined to the final point of the first vector. Clear? And after that finally we have to join the initial point of the first vector and final point of the second vector with the another vector. Now this is the A plus B. That is what? A plus B, nothing but this I am saying C. Clear? So this is the addition of vector children. Very simple. We are taken now, this is the A, vector A, initial point, final point or head. So to that what you have to add? Initial point of the second vector must be added, or tail of the second vector must be joined. This is A and this is B. And after that actually how can we add? So if you want to like this, if you can add some more vector, that should be like this. So its initial point must be given to the final point. But in this case we have to give in reverse. Clear? So that is here A plus B. Got my point? Children, A, B joined properly. And actually next is what? We have to, if any vector is there, that should be given like this. Initial point and this is the final point. But in reverse, we are giving like this. A vector is joined from initial to the final point of the second vector. Now it is A plus B. Children, A plus B. Clear? And now here, now it is, children, I am taking, this is B. This is what? B. Don't confuse. This is B and this is A. Watch at this one. And I am taking now, this is the A. This is B and now it is A. This is vector B, like this. This is vector B. How I am drawing, lighting like this is, I am drawing separately here. I will show A plus B and B plus A both are in same direction. So now this is a B and for that what I am joining? A. Vector A. Initial point of second one. Now in this case I am going to explain B plus A. That's why in this case B is the first vector and A is the second vector. So this is the B is the first vector and A is the second vector. Initial point of second vector. Initial point of second vector should be joined at this point. That means what? Initial of the second is given to the final of first one. And children, and now this is what? This is what? B plus A. Initial point of first to the final point of second. We will join like this, B plus A. Clear? This is B and this is A. Clear? So like this. So if you can take again, this is what? This is A. If you can take, this is A, and if you can take, this is a B. These two must be same. Okay, children? Okay, don't go very deeply. Don't go very deeply. Simply here you have to remember that is the addition of vectors. A, in this case, children, A plus B is equals to B plus A. Clear? So that obviously committed to law. Addition of vectors can obviously committed to law. And children, now here addition of vectors can already obviously associative law. Associative law. That should obviously associative law. That is means here A plus B plus C is equals to B plus C plus A. So in your textbook also diagrams are there. You can watch, after watching the video you must check it. A plus B plus C is equals to B plus A. Here association what it is, first A and B added, for that C is added. Now here initially B and C added and again finally A is added. So children, watch carefully here. First thing is again same thing. This is A. This is what? A. Initial point, final point. For that what we added? B. Clear? This is A and this is B. And after that we are joining these two. Now this is what? A plus B. Clear, children? Same thing. Initial point of second vector is given to the final point of first vector. And again initial point of the first vector and final point of second vector must be joined with another vector, that is what? A plus B. Clear, children? Now this is what? A plus B. For that, children, I am going to add like this. This is C now. Like this. So this is C. What is that? C. This is A plus B. This is what? A plus B. For that what I am added? C. This is what? C. Clear? A plus B plus C. So now how we can join them? Like this. This is what? A plus B plus C. Clear? So A plus B plus C. So now this is what? This is what? A plus B plus C. Okay children. Now in this case you have to watch again carefully. This is B, this is B, and this is C. This is B and this is C. Now what did children? This is B and this is C. Now what did children? What it is? B plus C. What is that? B plus C. No need to confuse. This is B and this is C. And if you can join them, this is now what? B plus C. This is what? B plus C. This is what? B plus C. Okay, now I am taking this is now A. What is it? So this is what? B and C. Here now it is B plus C. This is B plus C. Clear? So this is B plus C. And again this is B plus C. For that what you have to add children? We have to add A. So here arrow mark is like this, but now in this case you have to take like this, opposite. So now this is what? A. This is what? A. So B plus C and this is A. Clear? Now what you have to say children? This is B plus C and this is A. Clear? B plus C and this is A plus. Clear? This is what is children? B plus C. Okay, and this is what is children? This is A. If you can keep arrow mark like this. Okay, now it is what? B plus C plus A. Clear? This is already B and this is C and this is B plus C. For that we add A. Now we want to get this is A plus B plus B plus C plus A. So these two are equal. So this is children, it can obviously associative law also. So children, no need to confuse and don't bother about the addition and subtractions diagrams because they never ask in examination point of view. Clear? Just simply have to know idea about the addition of vectors and subtraction of vectors. For that purposely I am explaining. Okay children, and this is A plus B plus C and B plus C plus A. Okay, and now children, here children, this is vector A. This is what? Vector A. This is vector A. And if you can take, this is what? Minus A. What is that? Minus A vector. Both are in opposite directions. Both are in opposite directions. Then we will get null vector. What do we get? Null vector. Because magnitudes are in opposite directions, that's why we want to get null 0. If you can add a vector and its opposite vector, then it gives a null vector. If you can add a vector or null vector, sorry, if you can add and its opposition vector, then what do you get? A null vector. Clear children? And next children, subtraction of vectors. Subtraction of vectors. So children, watch carefully. This is the vector A. What's that? This is the vector A. And children, this is B. Children, subtraction of vector. How we can subtract them? Just we have to watch it. This is the vector A and this is vector B. Clear? And now this is what? It is B and now it is minus B. Clear? So here generally A is there and B is there, children. A minus B means what, children? Nothing but A plus of minus B vector. If you can add the vector A and minus B. Clear? If you can add the A vector and minus B vector, then only we get the A minus B. Clear? That means subtraction also again from addition. So this is the vector A and this is minus B. Then if you can join these two, then we will get A minus B. This is what? A minus B. And children, so here, and this is what? A plus B. A plus B. Clear? This is A minus B and this is A plus B. So tell me now children, A plus B and A minus B both are equal or not? They are not equal, because A plus B is in this direction and A minus B is in this direction. Clear? So during the A plus B I told you what's that? This is A and this is B. This is vector A and this is vector B. Now what are the children? This is A plus B. It is what? A plus B. Clear? So this is the vector A and this is the vector B. Clear? This is what? A plus B. And now we can take children, this is B and this is A. Now what it is? B plus A. So that means in case of A plus B is equals to B plus A. It obeys the commutative law in case of addition. But in this case, A plus B is not equals to A minus B. That means it does not obey the commutative law and it does not obey the associate law also. So that is about children, addition and subtraction of vectors. Okay children, so now what I am telling, that is the very important for examination point of view and further questions. For further questions also it is very important children. That is resolution of vectors. So resolution of vectors. Resolution of vectors. Most important for examination point of view. What is meant by resolution of vectors? Resolution of vectors is nothing but a vector that should be written as the combination of number of its components, or a vector that should be divided into its number of components. That should be called resolution of vectors. Resolution of vectors means a vector that should be divided into number of components. That should be called resolution of vectors. Children, for example, what we call unit vector. Generally, unit vector is nothing but a vector that should be having its magnitude equals to 1. A vector which is having its magnitude is equals to 1 and that will show in particular direction. That should be called unit vector. A vector which is having its magnitude is equals to 1. That is what we call unit vector, and that will represent some particular direction. So children, here in this case we are taking one coordinate system, that is here x-axis, y-axis and z-axis. So what I told you just now, unit vectors can identify the direction of the particular directions. That's why here children, I can represent the x-axis, unit vector I can be represents the x-axis, and j can be represents the y-axis, and k, unit vector k can represents the z-axis, I, j, k. So it is represents the j, represents the k, like that. So unit vector I represents the x-axis and unit vector j represents the y-axis and unit vector k represents the s. And now children, here in this case, here so here now this is the one vector. Here I am writing this is now axi. Axi is one component, or simply here I am going to write here simply this is the one vector, that is A. This is what? Vector A. Now that should be divided into two components. One is onto the x-axis, that is here axi, and this is on y-axis, it is there, and it is the y component, that is aya. Watch carefully children. x component of A is what? AXI. Clear? And y component of A is AY, simply AYJ. Already IJK values are 1, so that's why no need to say. So simply here this is AY and this is simply it is I and this is J and this is K. X component of A is AXI and y component is AYJ. Clear? And children, now here this is what? AXI, first vector, and this is what? Second vector AYJ. Clear? If we can, this is the first vector and this is second vector, we can add them. How we can add them? According to triangle law. Now this is what? A. Then here A can be written as A is equals to AXI plus AYJ. It is the vector form of A. Clear? A is equals to AXI plus AYJ. Now this is the vector. So in this way, children, a vector should be divided into two components. Vector A is what? AXI plus AYJ. Here AX is the x component of A, AY is the y component of A. According to additional vectors, what, right? A is equals to AXI plus AYJ. That is the vector, children. So children, here watch carefully here. Again same thing I am drawing here. This is the vector A and it will make some angle theta. It will make some angle theta. So it is what I told you, this is AY and this is AX. And if you can draw one normal like this, now it is what? AX and this is also AX and this is also equals to AY. So OABCD. OABC. In that AY are equal, I mean OC is equals to AB and OA is equals to BC. Clear? Got my point, children? Theta, this is the direction made by the resultant vector. That is what theta makes theta. And AX, AY, here AY equal, AX equal. So here I am drawing same thing, theta. From the diagram, children, what you have to write? I am going to write, children, here from this diagram, sin theta. Sin theta means what? Opposite side by hypotenuse. Opposite side by hypotenuse. Here what is the opposite side? What it is? AY by hypotenuse is what? A. Sin theta is equals to AY by A. Then what do, children? AY is equals to A sin theta. So its value is what? A sin theta. And similarly, what we have, children? Cos theta is equals to what, right? Adjacent side by hypotenuse. Adjacent side by hypotenuse. What is adjacent side? OA. Hypotenuse is what? OB. That means AX by A. Then what is, children? AX is equals to A cos theta. AX is equals to A cos theta. So in this way, children, one vector is divided into number of components like AX, AY, and then what it is the value of AX, A cos theta, and AY is equals to A sin theta. So children, based upon the resolution of vectors, there are so many topics coming in this chapter. That's why you must understand the resolution of vectors. So AY is equals to A sin theta and AX is equals to A cos theta. Then substitute, children, A is equals to what, right? AX means what? A cos theta I plus A sin theta J. So this is the vector form. Clear? A is equals to AXI plus AY. This is the substitute values of AX and AY. So this is the vector, children. And next, in this case, you have to observe, children, according to Pythagoras, what do you write? From this right angle triangle, what do you write? According to Pythagoras, what do you write? A square is equals to AX square plus AY square. Or simply A is equals to under root of ax square plus ay square. This is the magnitude of resultant vector. A is equals to under root of ax square plus ay square. So if you want to check whether it is right or wrong, just you have to check. What is ax value? A cos theta whole square plus a sin theta whole square. Just you have to check whether it is right or wrong. Then what are children? That is equals to a square cos square theta plus a square sin square theta. Clear? So from that, a is equals to what are children? A square is common. A square into what to write? Sin square theta plus cos square theta. This value equals to 1. Then what it is? A is equals to under of a square. So square root cancel, what you get? A is equals to a. So that's why what we select, that is the right. So this is the resolution of vector, children. So what is mean by resolution of vector? Resolution of vector is nothing but a vector is divided into number of its components. That is what we call resolution of vectors. So children, here we are taken one vector, that is a. A is equals to axi plus ayj. In that, ax is the x component, ay is the y component. I represents the x axis and j represents the y axis. I, j, k all are unit vectors. So children, in this case we are taken, this is the vector a, that should be taken as ax and ay. So in this case, what are children? A is equals to axi plus ayj. So to get the values of ax means what is the numerical value? Numerical value into I. I represents the what? For example, here I am going to write the same expression like this. A is equals to, here I am writing 3i plus 6j. 3i plus 6j. Here ax value is what? 3. A is equals to 3i plus 6j. Ax means what? Value means what? It is numerical value. And ay is j, it is 6. Ax is 3 and ay is 6. That means here in the equations we are getting some axi plus ayj means what it is? Ax is the one numerical value that should be on x axis and ay value is on y axis. That should be. So to explain the motion in a body, you must use the vectors. So children, here, that's why here what are children? A is equals to axi plus ayj. Clear? In this case, children, you have to go for now find out the ax value and ay value. Then you consider it will make some angle theta. Then sin theta equals to opposite side by hypotenuse and sin theta equals to ay by a. That is equals to what? A by sin theta. Similarly, cos theta equals to ax by a and that is equals to ax cos theta. We substitute those values in the equation. What you get? A is equals to a cos theta plus a sin theta j. And children, in this case, magnitude of vector is what? A is equals to under of ax square plus ay square, because this is what? Pythagoras theorem. Then what you get? Same thing. If you can substitute these values of ax and ay, what you get? Same thing. A is equals to a. So children, this is the resolution of vectors. Okay children, now you want to know about the two things here. What is position vector? What is position vector and what is a null vector? Okay children, same thing here we are taking. This is the 4 marks question, children. What is position vector? Like that. So this is the x-axis. What right? This is I and j and this is k. Now children, at this point we have selected one point, it is there. Clear? Motion in a plane. In a plane we have to explain the motion of the particle. For example, at this particle, at this point position, at this point P, there is one particle or one body, it is there. Then how we can write the position vector? This is the position vector now children, and this is the origin. Origin can be taken as O, and now this is the OP arrow. It is the position vector. Position vector. Position vector can be used to identify the location of a body in a plane. Position vector that should be used to, or that should be describes the position of the or location of a particle in particular plane. Clear? The vector which can identifies the location of a particle in a plane, that should be called position vector. So for example, we are taking xyz plane, 3-dimensional plane we are taken. 3-dimensional plane we are taken. So this is x, this is y, z. So x-axis, y-axis, and this is z. Clear? So then automatically here, this is the point. At this point, particle is there, and from the origin we have to observe OP is the now position vector, and I am taking that is R. So that R bar is the position, R arrow is the position vector. That should be written as xi plus yj plus zk. So this is the position vector, children. The vector which can be used to explain the position of a particle in a plane. That should be called position vector. Position vector generally shown as R arrow is equals to xi plus yj plus zk. We are going to explain that it is in 3-dimensional. And children, now in this case, again here, based on that we have to define the unit vector of position vector. Here R cap, that is the unit vector. That should be written as R by mod of R. This is now unit vector. Generally, the unit vector can be defined as like this. So what I told you, unit vector is nothing but which is having its magnitude equals to 1. That should be called unit vector. For a vector, how we can write the unit vector? That's the question here. For a vector, how we can write the unit vector? For example, here A is a vector. Then we will write unit vector is nothing but A cap is equals to A by mod A. Like that, here unit vector of position vector is R by mod of R. R is equals to what, children? Xi plus yj plus zk. Xi plus yj plus zk. Then by mod of R means what? What to write? X square plus y square plus z square. Square of the coefficients of x, y, z. So it is the magnitude. So mod of R is nothing but under root of x square plus y square plus z square. We will find like that. So for example, here I am taking now A is equals to what here? AXI plus AYJ plus AZK. Then unit vector of A is what? A by mod of A. That means what? A means what? AXI plus AYJ plus AZK by under root of AX square plus AY square plus AZ square. Clear? This is the unit vector. Clear, children? The vector which is having its magnitude equals to 1, that should be what we call unit vector. It's very clear. If you are writing cap over a letter, that represents the unit vector. And next thing is what? For a vector, how we can write the unit vector means like this. Vector by the ratio of vector by its magnitude. That should be called unit vector. Clear? The ratio of vector to its magnitude is called unit vector. So like this. So we will find out for competitive exams it is very important. In 2 marks also it is very important. Find the unit vector of A. For example, here example should be like this. Here some P is equals to 2i plus 3j plus 4k. Vector is some P is equals to 2i plus 3j plus 4k. Then here find the unit vector of P. Find the unit vector of P. So then what are children? P cap is equals to 2i plus 3j plus 4k by what, right? Under root of 2 square plus 3 square plus 4 square. That means what? P is equals to 2i plus 3j plus 4k by 4 plus 9 plus 16. So the value what we are getting, that is the unit vector of P. Like that. So this is our the unit vector. How we can write the unit vector for a vector. And next, children, finally null vector. What is null vector? If we can add a vector and its opposition vector, we will get a null vector. So here null vector can be represented as 0i plus 0j plus 0k. Its magnitude is 0, but it has some direction. Clear? A vector which is having its magnitude equals to 0, but it is in specific direction, that should be what we call a null point. It is what we call a null vector. the vector which is having its magnitude equals to 0 should be what we call 0. For example, null vector 0i plus 0j plus 0k, that means what? Nothing but here it is origin. This is the point here. At this point, from that point only we will move, it is along the x-axis. It can move from that point only, it is y-axis. From that point only we can move in z-axis. That's why maybe it is null vector, maybe it is null vector and its magnitude equals to 0. But from that point only we will go for in specific direction. So this is about the unit vector, null vector and position vector. So children, maybe this video is very lengthy, but you have to watch the video with very patience. That much of important topic. So I hope you understand. If you can understand this video, like, share, comment the video and subscribe my channel to get the all notifications. If you want to subscribe me, if you want to support me, just subscribe and press the bell icon to support me. Okay, we will meet in the next video with some other interesting topic. Bye, take care children.